recorded. So if you want to drop off, you don't want to be recorded, then you can drop off. But the recording has started.
All right.
Recording has started.
Fantastic. Hi, everybody. Welcome to the Chicago Suburban User Group meeting for the month of April. Today, we have our speaker, John Deardurff, who obviously works for Microsoft. He's a trainer and Microsoft certified trainer, and he's dealing with all data and customer AI engineer, a data and AI customer engineer for Microsoft. And he's the MCT regional lead for Eastern United States and a former data platform MVP. So he kind of knows what he's talking about. And he likes singing. So he's going to be talking today about some of the SQL 2019 redesign for the database engine recovery process to improve database availability and how to accelerate database recovery ADR. Provides lightning fast database recovery, instantaneous transaction rollback, and aggressive log truncation. I can't speak. So without further ado, I'm going to hand it over to John. And if you have any questions, please put them in the chat or raise your hand and we will address them when there's breaks.
Absolutely.
Thank
Absolutely. Oh, did I jump? I didn't mean to jump on your.
No, that's fine. Thank you.
Thank you. Amina, did you have anything?
No, I don't have any questions right at this point, but I'd like to thank all the participants who joined in today. I know you're putting a big effort and time commitment, and it's a great effort, after work joining the team. So I would encourage you to join other user group meetings because most of them are online now. Side effects or the silver lining of the COVID. Okay, so thank you very much. And John, to you.
Thank you, everybody. My name is John Deardurff, as you might have mentioned. We're going to talk about accelerated database recovery. Lowry and Amina briefly introduced me. There's my information again. If you'd like to follow me later on Twitter at SQLMCT, my website, SQLMCT.com, GitHub, my slides and my demo code is out at github.com/SQLMCT. I kind of branded the SQL Microsoft Certified Trainer. All my performance tuning, nothing's proprietary out there. So if you see something, most of that's my own custom information. Nothing's from Microsoft, but just legal disclaimer, anything out there is not officially Microsoft code. It's my own code, so use it at your own risk. Anything you find, my own personal recommendations. Same thing with this session, just to put that out there. I have a bunch of certifications. If you'd like to know more, that's why I have the website. I don't make any money off the website. Everything I put out there is basically for performance tuning, additional information. Like I said, this slide deck and my demonstration code is out there on my GitHub under a folder, performance tuning, accelerated database recovery. So what are we going to discuss over the next hour? Last time I did this, I had an hour exactly. So we'll see. We might go over, might not. We'll see. So this session, we're going to discuss accelerated database recovery. What is it? We'll look at the current database recovery strategy. When I say current, what we've been using for the last at least 25 years. I'll go back as far as SQL 7.0, SQL 2000, the database recovery process, ARIES. I think the official term is ARIES. I forget what ARIES stands for. It might be on the slide coming up. But we'll walk through the current database recovery process to kind of identify our pain points that we run into when we are trying to recover a database. Not necessarily restore. This is part of the restore process, but recovering maybe from rolling back a transaction, or we have a long-running transaction that needs to roll back, or we're having issues with our transaction log filling up, or needing to back up the logs frequently because they are filling up. I just kind of mentioned that. But trying to recover quickly, getting back up and running. So we'll talk about the current process. I'll walk through the four core components of accelerated database recovery. It really just, they've added 4 pieces to the puzzle to streamline and improve accelerated database recovery. So as we go through what each component is, the 4 components, then we'll walk through the newer accelerated database recovery process. By newer, SQL Server 2019 and later. It is in Azure SQL. Hey, there's Amina's got that out there. Thank you, Amina. It is in Azure SQL Database Managed Instance. That's how much Microsoft likes it. It's in their product. It's enabled by default for everything out there in Azure to help them. So probably the next 20-25 minutes will be the presentation. And then the last 25 minutes will be a demonstration. I'll show it to you live and in stereo. Well, if you have stereo. And so that's what we're going to cover. So what is it? Well, I just remembered something I wanted to add on to. I meant the last time I taught this to add a bullet. Now I forgot what it was. All right. Accelerated database recovery, as I mentioned, is a new SQL Server Engine feature. So it's built into the database. There's not much configuration you have to do. You just enable it. I'll show you that on the next slide. That greatly improves database availability by completely redesigning the recovery process, how we recover from failure. Rollback transaction. We'll see a few of those items here in a moment. But it sounds like a marketing. Greatly improves. When we go through the demonstration, you will see where our recovery process will go from 30 seconds to less than a second. And the number of records I'm working with, or what we will be working with, 750,000 records. So the recovery process is that instantaneous. So it's going to allow me to quickly get my database back up and running when bad things happen. When bad things happen to good administrators. We all have bad days. Normally on Mondays, some days on Tuesdays. But we all have those days where we need to restore the database. And a lot of times they're restoring the database if something bad happened. The longest phase, either restoring the database and then running through the recovery process, replaying and rolling back the transaction log. Or if it's even just, a long running transaction. Maybe I was performing a bulk import, importing 1 million records into my database. And I wrote my code incorrectly, so I'm doing each insert row by agonizing row because I'm a bad developer. Shouldn't do that. I forgot to batch my transactions. But if I did have that long-running query, or we have someone, a developer who has a long-running query and a failure happened, there was an error. How long is it going to take to roll back that transaction? Just in a normal day-to-day process, even when tragedy doesn't strike. I just may have a bad developer or a developer who made a mistake and said, well, we're going to insert these records. Oh, I made a mistake. Let's roll back. If that transaction has been running for an hour and a half, it might take an hour and a half to roll back, where I'm starting to lock other people out. Because sometimes I feel like I'm locked out of my database, as a song, for so long. So the benefits of ADR, from now on, I'm going to say accelerated database recovery. ADR. So I don't have to say accelerated database recovery 50 million times. That's what I mean. It's going to allow me to create a fast database recovery and consistent. I'm still going to meet the ACID properties of recovery. If you're not sure what ACID properties are, I have a blog post on it on my website, sqlmct.com. Shameless plug. I make no money off of it, so you can go out there and see it. But atomic, consistent, isolated, and durable. My transactions are still going to be all or nothing, consistent. All the transactions that need to be written will be written. Any transactions that do not need to be written to the database will not be. Still isolated, doesn't really deal much with a little bit with the locking. Improves some of the locking issues we have with transaction log. And durable, because I can recover. So it still conforms to our normal, hello friends. There's my SQL MCT. All right, so there you go. I also have a bunch of community resource links. There's a little tab that says community resource where I point out to everybody else in the community. out there. Another shameless plug to everybody else in the community. Hashtag SQL family. All right. So aggressive log truncation. Because of the process we have now, my transaction log is going to be so much smaller. How much smaller? We'll see in the demonstration. But it's going to reduce the size that a side benefit. It's not only going to speed up the recovery of my database, but it's also going to allow me to keep a much smaller transaction log, because I don't have to keep track of long running transactions anymore. I know you're all thinking, how does this work, John? I'm getting there. We'll get there. And another benefit, I don't know if it's a benefit or not. I think it is. It is available in standard edition. I put that on there because I always think a feature like this, you would only get it in Enterprise Edition. It's in Standard Edition, which means 2019 and later, you can use it in Standard Edition. It's also, you can use it in older versions of the database as long as you have a 2019 instance. You can use this on older databases as well. I'll demonstrate that. All right, so there's a lot of features. We'll see some more features along the way. One of them, I mentioned aggressive log truncation. It's going to improve performance with their high availability because my logs that I need to go from the primary to secondary are going to be much smaller. There's less to replay on the other side. So just another one side benefits we'll see along the way. There is a fifth bullet that I forgot I need to add on there. I keep saying that every time I teach this. Okay. So before we get into the components, excuse me, before we get into the components, how do you turn it on? Well, Azure SQL Database, you don't have to do anything at all. It's on. I think you can turn it off, but you can just leave it on. Again, platform as a service, Azure SQL Database, that Microsoft manage your backups and recovery process, they'll leave it on so they can do it there. But for 2019, it is not on by default for 2019, but you can turn it on. Just type in alter database, the name of your database, set accelerated database recovery equals on. Now, if you do not specify a file group, it will save your persistent version store into your primary file group. Now, I just said 3 terms that may not be familiar, so let me explain those 3 terms. File groups within your databases is where you can separate your data files or your data files into maybe different drives. Maybe you have a fast SSD drive you want to use for some of your data files, or a faster drives you want to use for data files that need more maintenance. So you can split them up into file groups. Well, with database recovery, we're actually going to get a version store. The version store is what's going to be used to store the different versions of my rows. And it's kind of the secret behind ADR. So I can actually just see a row version, or I can roll back to the previous version of a row instead of having to roll back individual entries in the transaction log. But I need to have that version store stored somewhere, or it's the persistent version store. That's the main component of ADR, is that there's a persistent version store. Think of it as your own personal TempDB database. If you've not heard of TempDB database, that's the database that's used to store your temporary objects, temp tables, things like that. But if you enable the recommitted snapshot isolation or items like that, those rows or those version stores are stored in your TempDB. And that's for all your databases on your instance. They all share the TempDB database. But when I enable ADR, I'm going to get a persistent version store to store my rows or row versioning. It's also going to side benefit alert, hashtag. It's also going to offload concurrency issues with my TempDB, because a lot of the things I typically use with TempDB before ADR is now going to be able to use my persistent version store. Is there a formula? Oh, I don't have my chat. I need to look at my chat real quick. Is there a formula or way to anticipate the size on disk that this file will utilize? You know there is. I would be happy to show you in 22 minutes. 22 minutes and 30 seconds, if I timed it correctly. I will show you how to see the size on disk of the persistent version store. Is it a DMV? I think it's a DMV, Dynamic Management View. Now to anticipate the size, maybe not. So there is some overhead. Thank you for that question. Probably one of the downsides to accelerated database recovery is the size on disk, as Lowry just mentioned. But the benefits are going to far outweigh disk size. And again, you're offloading concurrency from your TempDB to your persistent version store. And you can also store this persistent version store if you wanted to, that's that third line, into its own file group. So you can have a dedicated disk just for that persistent version store. You don't have to. Again, it's optional. If you just use the first two lines, alter database, accelerated database recovery on, it'll save your persistent version store, your PVS. From now on, I'm going to call it the PVS, persistent version store. I might say PFS, because I always think page free space and data pages. If I say that, I mean PVS. If I say PFS, I mean PVS, persistent version store. Again, if I don't specify, it saves it with my primary file group, which might cause headaches. That might be an issue I might want to look for. But I can offload it to its own file group. And we'll see that, and I will show you the code in the demonstration, the actual code for that. So that's how I enable it. Okay. Next slide. Next slide, please. There you go. So before we look at the components of the persistent version store, the actual new recovery process, how it works, let's look at the existing process, what we've been using for the last 20 some years, 25 years, if you want to go back that far. I don't have it on the slide. I thought for sure, I normally have the acronym. The technical term for this is called ARIES, ARIES, this process. The acronym stands for Algorithms for Recovery and Isolation Exploiting Semantics. I'm glad I never have to say that again. But this process, the traditional process we've been using, ARIES, Algorithms for Recovery and Isolating Exploiting Semantics is a technical term. Who comes up with these names? But this is the traditional process where we have 3 phases to our recovery process. And this is the recovery. This recovery process happens after I would do a restore. If I restored from backup my data from disk, or if I need to roll back a transaction, that's when this recovery process happens. Or there's actually a few other cases where the recovery process happens. Basically, something happened and I need to recover, get my database back into a consistent state. And it's the main reason we have transaction logs. So the first phase that happens, and this won't change much. The first phase is where I do the analysis phase. The phase that this actually determines the state of each, I had to look at the slide, determines the state of each transaction in the system at the time the SQL Server stopped. So it's going to look at the database, the data files, and the log files, and say, okay, what's the state of my transactions, the current state of each of the transactions. And based off that state, I need to determine whether the transaction has been committed, whether I need to roll it forward and write it to the data file, or I need to undo and roll it back. Now, the redo phase typically doesn't take that long. So after phase 1, the analysis phase, and again, this is our current recovery process, the analysis phase goes through and determines which transactions which transactions do I need to roll forward? What do I need to redo? So once I determine which transactions need to roll forward, I'll look at the data, the database, look at for the transaction, I'll look in, well, I won't go in that depth, but I look at the data file and the log file and look for the logical sequence numbers. And I'll roll forward any transactions that have been committed and need to be written to the disk. That's a fairly fast process. But I will still, when I do this, or during this recovery process, I will actually place a lock on the database as I'm going through the recovery or the redo process. So at this point, as I go through the redo process, my database is in a partially recovering state. might see pending or recovery pending state, saying that you might be able to access some data, you might not. So you might not be able to access. So there's still a lock on that database. That's going to play an important thing here in just a moment. The next part is where our headaches happen, where all of our problems happen with the recovery process. That's going to be fixed with ADR. That's a lot to promise. I just promised a lot there, especially if you've run through the undo phase. The undo phase is going to roll back any uncommitted transactions. So these are any transactions that may have began. You started the transaction, it's been running for an hour, hour and a half. Maybe you were importing a bunch of records and something, the server restarted. Server rebooted, comes back up. I need to, oh, that's the third reason, the server restarts. I need to go through this recovery process. So if the transaction hasn't finished, I don't know if it was almost ready to finish or it's going to finish in 5 hours from now. Since I don't know, since I can't commit, I need to roll back. So it's going to roll back, but it's going to roll back all the way, that's a long way, to the oldest uncommitted transaction. Or within the transaction log, if you look inside the transaction log and all the active VLFs, virtual log files, each of my VLFs or partitions within my transaction log will be active all the way back to the oldest uncommitted transaction. Because in my current process, I have to keep track of all those transactions if they've not been committed, because I have to keep track of them just in case I need to undo them, just in case of a failure. So that's the main reason I have to have large large log sizes, transaction log sizes, possibly. Now, if I'm in simple recovery model, don't care. But if I'm in full recovery model or bulk log recovery model, then I do care. So I need to keep track of every single transaction until they've been committed. Once they've been committed, then I don't care anymore. And then eventually I can truncate the log at the next log backup or along those lines. But if a transaction never commits, then I have to keep that active portion of that log for as long as or until I commit, even after a checkpoint. So a checkpoint is where I've written my oldest, or my checkpoint is where I have my oldest dirty data pages when they're actually written to the actual data file. So checkpoints are going to commit data or write data to the actual disk after they've been committed. But my transaction log still has to be open. The individual virtual log files within the log has to remain active all the way back to my oldest uncommitted transaction. So if Sally from sales started a transaction on Friday, began transaction and inserted a record on Friday and it never committed, maybe she forgot to write the commit transaction, nothing against Sally. Just somebody came by and said, hey, Sally, you want to go to lunch? She said, sure. And then they never came back from lunch. She shows up Monday morning like, oh, I forgot to put commit transaction. Well, that's in that log. That's the oldest uncommitted transaction. If she started it, begin transaction, insert record. If it never committed, that's the oldest active transaction. Probably someone found it over the weekend. So that could be an innocent mistake, could be a bulk import or inserting a bunch of records, but I'm limited in my log. I shouldn't say limited, but the size of my log could grow really, really large, especially if I am inserting a lot of records and I haven't batched my transactions. I could have a very, very long transaction, which means my recovery process is almost directly mapped to how long my oldest active transaction has been running. And my oldest uncommitted, not active, oldest uncommitted transaction, that's right. Oldest uncommitted transaction, if it's been running for 2 hours and I need to recover, then I need to roll back everything within that transaction all the way back to the oldest, which could be 2 hours, could be 8 hours, depending on how long that oldest uncommitted transaction is. That's my pain point. So long recovery process, large transaction logs. I can't truncate my log. until that oldest uncommitted transaction is committed. And during the recovery process, I'm going to lock out other people from being able to access the database until I'm done recovery. It could take, again, the recovery process is directly proportional to however long it takes to roll back that oldest uncommitted transaction. So that's our current process, our current headaches that we run into. I think on the next slide, some of those most common implications. I guess I need to switch these slides around. So as I mentioned, the common implications of our current environment, the recovery time is roughly proportional to my longest running transaction. Rolling back large batch operations takes a long time. If it's been running 2 hours, it might take 2 hours to roll back. And transaction logs might run out of space. So if I'm running into issues of my transaction logs running out of space, that means I've not allocated enough size, or I have a long running transaction, or I'm not backing up my, well, even if I'm backing up my logs, I'm still kind of limited to that oldest active transaction. It's kind of my stopping point. My stopping point, or kind of my pain point. So will ADR fix all this? Yes, and so much more. So here's the components, then we'll look at the new process, and then I'll show you a demo of doing all this. Actually, I have an FAQ first, so I have a slide for that. So persistent version store, I've talked about this already. It is a row version store like we have in the TempDB database, if I'm doing like snapshot isolations or things like that. My persistent version store will persist my row versions, or row versioning of each of my records. So if I insert, update, delete a row, I'm going to have a version of that row. I'll have what the row looked like before, and then the current row. So the row versions will have the previous state of the data. What did it look like before, and the transaction ID of that version. If I need to roll back, it'll actually have a fast undo, because I just look at, okay, I need to roll back. What was the previous version of that row? I'm going to mark this row terminated, or technically I'm going to mark it as aborted, saying the power went out. So I start back up, look at the persistent version store, and it says, oh, we need to roll back to, let's mark this one aborted, roll back to the previous version of that row. Which means I immediately just go back to the previous version, and I'm back up and running. I don't have to roll back every single part of the transaction. I just go back to the previous version of the row. So the persistent version store is what's storing these row versions. And again, this is probably the downside of accelerated database recovery, or actually there's two downsides. Forgot the other one, updates, which I'll point that out as well coming up on our frequently asked questions in 2 slides, maybe 3 slides. But my persistent version store is going to keep track of that information. So, as Lowry mentioned, I may want to put that into its own file group, make sure I have enough size allocated, but hold that thought. There's something else. There's something cool that will actually manage that. I don't know why I'm pointing at you guys. I'm pointing at my microphone, imagining pointing at y'all. All right. So persistent version store is what's storing that row, those row versions. My next component is the logical revert. This is actually what does keep track of the terminated or aborted transactions, and will asynchronously process the undos. So if there was a record, I rolled back a transaction. So that transaction was marked aborted. So I know I'm no longer going to use that. That logical revert is going to say, we'll keep track of those aborted transactions, and we'll perform rollback using the most recent committed transactions from the PVS. Yeah, did I say that right? Yes. So the logical revert will actually go back and roll back to the previous version. So that's happening. It's an asynchronous in the background. So you can still access the data and access the previous version of the roll. And also releases the locks. Release the locks. So during the recovery process, when I roll back to the previous versions, the rows have been marked as terminated. The logical revert actually does that. As soon as it rolls back, it immediately releases the locks. So previously, when I'm still locked out on my database, during the redo phase when I was redoing, and then I need to do the undo. Previously, I was going to be locked out until I finished the undo, the entire process. But the logical revert will say, okay, as soon as I roll back to the previous version, I'm immediately releasing the lock for those rows. So I'm immediately available. So my end users can have faster access back to the database. They don't have to wait until I recover everything. But it's only going to take milliseconds anyway, so they won't even know. The S log, you gotta take a drink real quick. What's in there? It's just Diet Coke or Diet Pepsi, whatever I have. The S log is my secondary log. I sometimes call it the special log or streaming log, depending on which documentation you read. I've actually read it 3 different ways. I've read it secondary log, special log, streaming log. The S log is not actually saved to disk. The S log is an area of in-memory. It's an in-memory log stream that keeps track of all the operations that are non-versioned. So when we think of versioned operations, we think of transactions, inserts, updates, deletes. But anything that is non-versioned, any entries into the transaction log that doesn't deal with the actual row, but might be maybe invalidating metadata information or all the information about creating locks, the different locks you might place onto an update or shared lock or exclusive lock on a record as you're updating it. That's not really dealing with versions of a row. So I don't need to store that information in the persisted version store. So that information is stored in memory. So that's going to really help me roll back anything that's non-versioned, because any non-version information is no longer in the transaction log. So that's going to keep my transaction log even smaller, less things I have to keep track in the transaction log. And when I roll back, I just check the secondary log. I think I misspoke. I did. The active part of the S log is in memory. It will, at each checkpoint, persist a copy of the S log to disk. I think I mentioned about 2 minutes ago that this is not persisted to disk. A part of it is. Since the last checkpoint, it'll write the persisted or have a persisted copy of this to disk. But it will be used during the redo and undo phase to redo or undo any non-versioned operations. But since it's in memory, it can happen really quick. And then my favorite tool, my favorite component is the cleaner. Bring in the cleaner. This gets back to, I mentioned there are 2 big issues with accelerated database recovery. One, updates, we haven't talked about yet. Updates will be slower. But my persistent version store can get large, can get huge. So how much space do I need to allocate on disk? That was the question that we had in the chat box there. Well, fortunately for us, we've got the cleaner. The cleaner will asynchronously, I'm not exactly sure how often, I think it's every 60 seconds or every minute, whichever one's the soonest. It will go through and clean up. So, and we will see this in the demonstration. It's actually part of the demonstration. If I don't move fast enough, it cleans up before I can show you the size of the persistent version store. If I wait more, I think more than 30 seconds or more than a minute, I'll show you. Here's the size of the persistent version store. If I talk for more than a minute, the cleaner comes up, has already cleaned up the persistent version store and shrinks it back down to almost nothing. So the cleaner is going to go through and clean up your persistent, all those rows that have been marked as terminated. If we don't need them, get rid of them. There's no reason to keep track of them anymore. Because if the records have been aborted or terminated, and I went back to the previous version of that row, why keep track of that information? Why keep track of the transaction that was rolled back or never committed? Where with the transaction log, I had to keep track of the oldest uncommitted transaction just in case I need to roll back. Now, since I'm using row versioning, I don't have to keep track of that information. I don't have to keep that in the log anymore because I'm using row versioning. Once I roll back, I don't care about that rollbacks process or the uncommitted transaction. I don't need it anymore. So I don't have to keep that information in the transaction log. which means my transaction logs are going to be truncated more often. My transaction logs are going to be smaller. Awesome. So that's some cool features. I just noticed I am wearing my Chicago Cubs hat. I didn't notice that. That's just for the Chicago user group. I'm teasing, all my hats are Chicago hats or Chicago Cubs hat, except for my Colts. I do have my Colts hat. All right, so just I sidetracked there. I know I needed a break there. C stands for cleaner. Bring in the cleaner. Go Cubs, go. Go Cubs, go. Hey Chicago, what you say? They're actually doing pretty good this year. Who knew? After they traded half the team. Okay, so recovery components. Those are the 4 core components of ADR. Now let's see how they work together. We've got this slide. We'll walk through the new process. I'll point to the white paper on where this, if you want a deeper dive, and then I'll have a slide for frequently asked questions. Will my database be larger? Will it affect performance? How is PBS different from the TempDB, and how does it affect? These are the most common questions I get during this session, because I've been delivering a version of the session since 2019 came out. So I kind of add that slide. Then we will get to our demonstration, and I will show you how this works. I just wanted to show you where we're at in the presentation. So you're getting, I know you're getting excited. John, show us how quick it is. I'm so excited, and I just can't hide it. I'm about to lose control. All right, so the accelerated database recovery process. Remember, previously we had 3 phases. We still have 3 phases. The 3 phases of the recovery process, but we're sliding in those extra components, the 4 extra components. The analysis phase is still basically the same. I'm still going to analyze what's the current state of my transaction, but I'm going to compare, I'm adding in 1 extra part to this part. When I analyze what are my active transactions since the last checkpoint for the oldest dirty page logical sequence number, what are all my versioned operations in the log, the transaction log, and I'm going to reconstruct the S log either from memory or the persisted S log records that have been persisted to the local disk. I'm going to reconstruct. Why can't I say that word? So normal regular analysis wants to what are my active transactions that need to be rolled forward, rolled back, but also look at the S log to look at my non-versioned operations. So that phase, the analysis phase, is almost the same. The next phase is 2A or 2B. To be or not to be? Is 2A. That is the question. But the phase 2 is actually now broken up into 2 parts. Previously, phase 2 had to redo all the way back from the oldest oldest uncommitted transaction in the transaction log and play forward everything. So if I had a really long transaction log, I still, even for the redo phase, I had to go all the way back to the oldest uncommitted transaction, even if my transactions have been committed, even up to the oldest dirty page or the last active checkpoint, or the last time I did checkpoint. Now, I don't care about that because I've got the version of the row. I know the current version of the row. Everything before the checkpoint, I don't care about anything before the checkpoint because I don't need that information anymore because I have the current version of the row in my persistent row version store. So the only thing I need before the checkpoint is any of my non-version operations, any of the non-version operations that's stored in the S log, either in memory or persisted. Is going to be very small because I'm only storing small little, we placed a lock, we released a lock. So very small little, it's not really much IO just to read, there's a lock, or lock, unlock. We change metadata invalidation. So the S log, that's going to happen in less than a second, less than a millisecond to roll that forward. I read it from memory, boom, done. All I really need to do now in phase 2 is just read since the last checkpoint. How often checkpoints happen? Every 5 minutes, 10 minutes, however often they happen. So I check the transaction log since the oldest checkpoint, not the oldest uncommitted transaction like I traditionally did, which is going to be a very, very small part of the transaction log. And at this point, this is where the logical revert, since it reverted back, is releasing the locks. I don't have to have a lock on the data file anymore because we have the current state of the rows, the current state of the rows with the logical revert. People can now access. I have full access. All my locks are released. Reduces contention, reduces concurrency. People are back and accessing the database in a matter of seconds, as opposed to waiting until the entire undo phase happens. Which again, the undo phase is where my pain point was, because my undo phase had to roll back all the way back to the oldest uncommitted transaction. So that's why I still had a lock on the database, so I could still undo those transactions previously. But since now I'm just going back to the previous row, and the logical revert will revert it back to the previous row, release all the locks on all those rows that have been marked as aborted. Is that right? Yeah, as aborted. Now, once I have that, I release, everybody can access the database. I still need to do the undo phase. The undo phase, though, everything before the checkpoint, all I need is the non-version information from the version store, because at the checkpoint wrote everything that committed to the database. Everything before that has been marked as aborted, or anything that is not committed has been marked as aborted. Anything after the checkpoint, everything after the checkpoint, I still need to undo. So I'm just going to do the undo phase back to the oldest checkpoint, as opposed to all the way back to the oldest uncommitted transaction. Amina, did you have a question? I saw your light shine. No? Okay. I see her circles coming up, so I wasn't sure. Yeah. So really good stuff. So hopefully you can see right there, my recovery process, the key point, we saw the 4 components, but the key point is I only need to keep my transaction log to the last checkpoint. I don't have to keep anything in the transaction log older than the oldest past the oldest checkpoint. So every time I do a checkpoint, that's all I need for the transaction log, which means when I do the checkpoint, truncate the log, which means my transaction log bonus side effect, I can keep my transaction log really, really small. I don't need that information going all the way back to the oldest committed transaction anymore because I'm using row versioning. I'm just rolling back from this record in the persistent version store. This row is marked as aborted, logically revert back to the previous version of that row. So I don't need to know how to roll back a transaction if I just say go back to the previous version of that row. That's the magic. That's the magic. So a bunch of side benefits. All right. Where did I get all this information? Am I lying to you? I probably am. Probably lying to you. There is a white paper out there. I've got the link. I'm actually going to click on the link to go out there. Before it was called ADR, it was originally called Constant Time Recovery. There's a white paper if you really want to deep dive. It's about 12 pages. I'll put that in the chat box for you all. So before it was called Accelerated Database Recovery, it was called Constant Time Recovery. And it goes through everything I just said, even more in depth into the logical revert, the background cleanup process. If you really want to get into their Aries recovery, compare the difference between Aries recovery and constant time recovery. So if you really want to read the white, it's 12 pages. I've read it about 5, 10 times, 6 or 7 times. I had it memorized at once. I forgot it. But I have gone through and read it a couple times. This is an interesting read to help you go to sleep. But the reason I put this out here, because I always have someone ask me, John, you're lying to us. Or is this really how it works? Or can you get more in depth? I could, but not in an hour. So if you want to read more, you can. But another reason I would point out this white paper is I always get back how fast am I really speeding up my recovery process? and how does it affect my different workloads? So they have different charts. They show, I think right here, the computer, when they experimented using it, they're using a workstation, 4 sockets, 40 cores, 2 gig or whatever that server is right there, 1.5 terabytes, 1.21 gigawatts. Great Scott. Wait, is that right? 1.21 gigawatts? Oh, sorry. I went back to the future there. All right, so use that server and they tested. So they have this little chart here based off inserts, updates, deletes, workload performance. And if you really want to read through that, you can. But the reason I'm putting this out, because I stole this picture. And whenever I steal pictures, I make sure I document that in my slides, or make sure I document it. It is documented on my slide. So I always mention the main dude up here. What's his name? This guy. These people at Microsoft that worked on that project. I don't know any of them. Surprisingly, I don't. Do I? I don't. And so I did steal where was that? Where was it at? I did steal this picture. It does get into logical sequence numbers, things like that. But I did steal that picture from, well, you can see the slide right here. Because I did get the question the first time, the second time. How is it improving? How is it improving my recovery times? What's the workload? Show us the numbers, John. And I said, I don't have a server set up, a real world example where I can insert, update, delete 200 million records. I guess I could have done an O-stress test on my laptop. That's not real world. But fortunately, in this constant time recovery white paper, they did the work for me. And you can go through page 10 through 10, 11 to 12, goes through this. So on the left-hand side is my recovery times without CTR or accelerated database recovery. The right-hand side is with accelerated database recovery. Now, I'm also going to point out, this is another example, going to a Power BI class real quick, or presentation. There's a little presentation class, bad instructor. This is an example of a bad visualization because it looks like it's comparable. But look at the y-axis. This is 3,000 seconds. This is 15 seconds. So bad visual, but I copied it directly from the white paper. So I just want to point that out. So when we're talking here, this left-hand side, this is saying for if I'm inserting 200 million records, it typically would take, I'm sorry, this is not a recovery times if the number of rows I was inserting, updating, deleting. During the analysis phase, redo phase, undo phase. I don't think I explained the chart correctly. So without CTR, you see the analysis phase was hardly anything. Redo phase, you can see for inserts, updates, deletes. The undo phase, how long it took. In almost every situation, the undo phase, when I was undoing 200 million records up and above, took quite a while. Now on the right-hand side, this is up to 15 seconds. So if I was actually taking this chart, this entire chart would fit down into like right here, like this part. This entire chart would be down here under 15 seconds. It'd be like this big, this big. Hello, Bob. It's Bob. You missed all the fun stuff, Bob. So again, data visualization, if you're building Power BI reports, keep that in mind. But you can see the analysis phase is taking the longest period of time. The redo is taking the longest period of time. The undo is non-existent, almost non-existent, except for some reason when I'm inserting 50 million records. For some reason, the undo phase took longer there. Why? I don't know. Read the white paper. But even the longest was deleting 10 million records. Not sure why that took a long time. 15 seconds. That is much faster than anything I have on the left-hand side. Anything even close, well, maybe recovery time here, maybe inserting 10 million records, the undo phase. So we're going from 3,000 seconds for how many rows to 15 seconds or less using those very large workloads. Okay, and again, you can go more detail with that white paper if you would like to. All right, one more thing. Oh, Darn it, I saw it again. Some FAQs, and it's all about that base, no trouble. I accidentally deleted that in the TA here, database in class once. When I was doing a performance tuning workshop or something, and I keep trying to fix it, and somehow it keeps coming back. It's one of those things that keeps haunting me, where the TA got deleted out of my accelerated database recovery. I think it actually happened at a past summit or a SQL Saturday, actually. Or maybe I was typing this in. So my frequently asked questions before we get into the demonstration. Ooh, Tim, I am going over a little bit. We'll see. Will my database be larger? Yes. It's not one of those, it depends. It will be, your database will be larger because I am storing the persistent version store. But according to that CTR white paper that I read, that was on the previous slide, for every 50 million modifications, it adds 1 gig to the database. The benefits of being able to have fast recovery, as opposed to adding 1 gig to your database for every 50 million, I can live with that. Most companies can live with 1 gig of storage. Considering 1 gig of storage, what does that cost you? $5 now, maybe. Not like the old days, not like 95, it cost you $200. Will it affect performance? It depends. There's your SQL answer. For write-heavy applications, yes. Most commonly, again, according to the CTR white paper or accelerated database recovery, heavy update workloads will increase your CPU utilization 13.8%. That's the other downside. I mentioned the 2 big downsides to ADR is going to make my database larger, but we have that cleaner that's going to clean it up. So that's kind of a push. And you can see that adds 1 gig for every 50 million. Your biggest negative is that it is going to affect your CPU utilization for heavy updates. Can I balance that? Is that going to be balancing fast recovery versus fast updates? I'll take that 13.8% or 14% if you want to round up. I'll take that hit, especially since if I can scale up or scale out, especially if I'm using platform as a service, I can scale up a little bit to adjust for that additional CPU utilization of update. Because if I can tell my boss, well, we were here Saturday and it took us 8 hours to restore a database and recover, but our updates were faster during the week. Or I could say it took us 3 seconds Friday afternoon to restore and recover a database. I shouldn't say to recover from a failure, but it's slower to update. I'd rather have that trade-off. Again, that's me. It depends your environment. You might have a boss says, we can't handle 14%. We can't handle it. Like, all right, I'll be here Saturday every time the database crashes. You'll pay me overtime. Or I'll call John because he needs more utilization himself. He needs 13.8% utilization. How's PVS different from the version store in TempDB? PVS stores versions in the user database rather than TempDB. Awesome. So if I'm using snapshot isolation or recommitted snapshot isolation for transactions, and I've enabled ADR, that's going to be offloaded from the TempDB into your persistent version store. So a side benefit, I'm reducing concurrency on my TempDB, which could be a big performance improvement. Again, we won't get into details of performance improvement on TempDB, but that's a side benefit. And I mentioned earlier how it affects availability groups, small transaction logs. So let me get into my demonstration. It's demo time. It's demo time. Okay. I did talk longer than I normally do. I got 6 minutes for the demonstration. 6 minutes. 6 minutes. All right. We might go 10 minutes. We might go over. I promised an hour. We're going to go over a little bit. So this is my code. Again, this code is on my github.com/SQLMCT. You can borrow my code. Do I have the disclaimer down at the bottom? I think I try to put all the Microsoft, there you go. For all my sample code, I put the Microsoft disclaimer. This sample code is provided for the purpose of illustration only and is not to be used in a production environment. Use as is. Use at your own risk. This is John's personal demo code. So only use it if you trust me. All right. Having said that, you can copy and paste if you want to. I did the legal Microsoft disclaimer. Okay. So I'm going to, first thing I'm going to do, I'm going to create a brand new database called ADR demo, just so I have a brand new database to work with, just so you can see I'm not playing tricks on you. I'm just doing a brand new database. So I'll go ahead and do that. Boom goes the dynamite. Now I'm going to add a file group. I'm going to create a file group where I can store my persistent version store. Real world environment. I had someone catch me on this. I'm putting both my data file and my secondary data file on my D drive, which is SSD drive. Real world environment, you would put your secondary file group on a different drive. I only have the D drive. That's my only option. All right, so alter database. Okay, alter database. So I'm adding a file group. We'll see if it actually works. I have run into an issue with my code. I haven't been trying to troubleshoot it. Been stuck with Synapse performance tuning, so I might still need to troubleshoot something coming up. Okay. Now, let's check my change compatibility level. This is an interesting feature, side benefit. ADR is a feature of 2019. I currently do not have it on. I've not turned it on. I just created ADR demo. If I checked, let me actually check first. Yeah. So ADR demo currently compatibility level 150, which I believe is SQL Server 2019. ADR is currently not on. I can change my compatibility level of my database to a previous version. So I'll change it to 140. So you can see 140. So was that SQL Server 2017? If I got my versions correctly. I'm bad with conversion levels in my brain, my brainy parts. So this is actually going to work on a 2017 database, as long as you're running SQL Server 2019. I haven't tried how far back I can go. Okay. Now, I have not turned on ADR. I'm going to insert 750,000 records into the ADR demo. It's going to insert 750,000 records with the middle column saying I'm going to have a random number and JD insert to show that I inserted. I'm going to create a non-clustered index for no apparent reason. I'm going to create the non-clustered index to speed up my reads because I took a performance tuning course at some point. Actually, I read it just to make sure my select statement or selecting is a little bit faster. We're not waiting a long time. All right. So now I'm going to look at my data. We're going to look at it now. Look at it now, John. Keep yelling at myself. So here are the 750,000 records, account ID, identity field, random number, JD insert, and you see I just modified it. I put it in at 757, and it took about 13 seconds to insert. All right, now we're going to get in and start testing. Take a drink real quick. Thank you very much. All right. This statement here, I'm going to set statistics time on just to see how long it takes to delete. This is without accelerated database recovery on. I've not turned on ADR. So I'm going to delete those records, the 750,000 records I just inserted. Notice that I began the transaction. I'm deleting all the records. Bad John. Deleted all the records without a where statement. But it's going to go through and delete all those records. How long is it taking? 16, 17, 18. This is without ADR, accelerated database recovery. So it should take, how long did it take? About 26 seconds. So I'm going to copy that, and my note says copy that down to line 103, because we're going to compare and contrast it here in a little bit. So I'm going to copy that to, actually I added a line, so 102. I need to fix my code. So that's what it's going to be without ADR. Let's go back up. Where's that? Now my began the transaction. I've not committed the transaction. I began, deleted, check the time. Let's check to see the records were deleted. They're gone. Where'd they go? I just deleted them. But remember, I began the transaction. I've not committed. I've not committed or rolled back. Let's check our transaction log. So our traditional transaction log, I'm going to show it before the checkpoint and after the checkpoint. So again, I deleted the records, begin the transaction. I'm going to use this dynamic management view to see the size of my transaction log before and after the checkpoint. Without accelerated database recovery, it's about the same. The size used 741 meg, log space and percentage, a little bit more after the checkpoint because I had to have an entry that I just did a checkpoint. So it's like 95.57% as opposed to 95, but more or less basically the same. So I do not have the aggressive truncation at checkpoint like I will with ADR. We'll see that. Okay. Now I'm going to roll back the transaction. I'm going to roll back the transaction, and again, rolling back is going to initiate that recovery phase because now I have to recover all those 750,000 rows I just deleted. I guess I should have done that while I was talking. So this is going to, how long did it take previously? Was it 23 seconds when I deleted it? So rolling back should be close to the same. Maybe a little bit less, maybe around 23 seconds, we'll see. 14, okay, a little bit less. But it took a while to roll back. Took 14 seconds to roll back or undoing the deleting the 750,000 records. So let me, did I copy that, paste that on line 133? So we can compare and contrast here a little bit later. Is that correct? Too much, copied too much. Okay. And so we're going to go back up. Checkpoint, checkpoint. Is this delete? Notice there's no commit. Okay, good. Log space, roll. Okay, roll back. How long does it take? Hey, John, be sure to paste. Okay. Are the records back? So I rolled back the deleting. My records are back. So I rolled back deleting the record. So I do have all the JD inserts. Went back to 757. And I'm still selecting. So it's going to take a second. Even with the index, it takes a while to select. Now, by the power of Grayskull, a little He-Man reference, I'm going to alter database. I'm going to turn ADR on. Line 88, I've been running into a problem. I'm going to try to see if it worked. This code has worked perfectly for over 18 months, or when I first created the code back to SQL 2019 when I first started doing it. A month ago, it stopped working, and I haven't figured out why yet. Where if I turn it on, I get a syntax error. So if I execute, I get a syntax error near persistent version store file group. I haven't figured out why. It only happens on my machine. It's one of those, well, it works on everyone else's machine. Who would I have? Oh, David Klee. I don't know if anyone knows David Klee. I had him looking at the code. He goes, I don't know. He was like, it works on my machine. I've asked, like, it works. So I can't see anything syntax incorrect. All right. So I'm still troubleshooting. I think I just need to rebuild my SQL Server because I've been using this for 3 years, and who knows all the damage, all the different bad practices I've done on this laptop the last 3 years doing performance tuning classes. So I am going to turn this on though. I'm just not going to store it into a separate file group. So when I turn it on, it will just save the persistent version store to my primary file group. Better practice, I should have saved it into a secondary file group that I created earlier. I'm still going to troubleshoot that. I think I just need to rebuild my server at some point because I'm getting some other flaky things happening, but that's just kind of weird. I've not been able to figure out the syntax here. Okay. So let's check, is it on? It is on now. Database is still version 2017. And here, Howry's question, is there a formula or way to anticipate the size on disk that this file will utilize? Dun, 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 yes. The dynamic management view, transaction persistent version store stats. This is going to tell me the size of, have you patched? That's probably what it was. My server patched itself, or maybe I need to patch. Or maybe I did, maybe I automated it, patched my server and I need to, who knows, probably. So it was probably forced. It was probably pushed down to me. Now that I think about it, that's probably is what happened. All right, so this dynamic management view will show me the size Again, you can borrow my code. It's out there on my GitHub. Will show me the size of my persistent version store. So if I look at the results, the current size is 0, and I currently do not have any aborted transactions. I've not rolled back any transactions since I've enabled ADR. So there's no space being used. Okay. So now I'm going to begin the transaction again. Same thing, I'm deleting the records. Execute. Previously, it took 26.2 seconds to delete the records. This time, with ADR, with ADR turned on. I move her a little bit. Probably got about 5 more minutes. So you can hang on 5 more minutes. We'll get finished up here. So the deleting the records took 25. So it took a little bit longer to delete. So let me copy and paste and compare. Took me the elapsed time, it was actually a little bit less elapsed time, but more CPU time. There is a difference. If you'd like to know the difference, that's a whole nother session. Getting into set statistics. I can't remember what, I have a session on that somewhere. So it did take a little or less elapsed time, but more CPU time. Okay. Let's check my transaction log. How much space is being used? Remember, without ADR, it was almost identical, deleting those records. Let's look at the transaction log. I think it was, what was it, 541 meg previously? So deleting the records from the transaction, or deleting the records, since I have row versioning, my transaction log before the checkpoint is small, but after I hit the checkpoint, since I can aggressively truncate the log, since I only need everything since the checkpoint, this is all I need, and that, so my log file is going to be smaller. Side benefit, hashtag side benefit. So with ADR on, my transaction log is smaller, another benefit. That's just from the checkpoint. Well, what's the size of my persistent version store? This is the same code I ran previously before I deleted the records. So my persistent version store is 82 meg. Those are the 750,000 records I deleted. So I had to keep track of, I'm now keeping track of the row versions in the persistent version store, showing that I just deleted 750,000 records. Remember, my transaction's still active. I go back over here. I did the begin transaction. I do not have a commit. I wrote a checkpoint to the transaction log. So my transaction log is smaller. Remember, previously it was 541. Now I'm dealing with 541 megabytes. My transaction log is smaller. It's even smaller there because I did a checkpoint again. But my persistent version store, because my persistent version store is storing the row versions. But I've not aborted a transaction yet. I've not rolled one back. So there's not one there. That's the next thing I'm going to do. So now I'm going to roll back the transaction. This is the magic. Nothing on my sleeve because I have a short sleeve shirt on. Previously, I'm going to talk, how long does it take without an ADR? You can kind of already see what's going to happen. Previously, to roll back that transaction without ADR took 14 seconds. With ADR, instantaneous rollback. How quick? How quick? Done. I didn't even get to 2 milliseconds. I just rolled back 750,000 records because there's row version. That logical revert says just go to the previous version. I don't need to go all the way back to 750,000 entries in the transaction log. I'm not even keeping track of that information anymore. Are the records available? I'm gonna make sure. I got 30 seconds. The records are back. Check the size of my persistent version store. Oh, I'm still selecting. It's still selecting. I wait till it finishes selecting for that previous. Let's check this since I rolled back. Hopefully I can check this. I have it. Okay, it was fast enough. My persistent version store is still 82 meg. It still has that information about the 750,000 rows, the current row, and then rolled back. And then I do have one aborted transaction because I just rolled it back. So it's saying in the PBS, we had one transaction that rolled back. Let's check our transaction log. Now that I've rolled back, What's the size of my transaction log? 24 meg. Wait a minute. Basically, I only need the space in the transaction log since the last checkpoint because I don't need anything else. So my transaction log, aggressive log truncation. And now if I go back and maybe I waited long enough now, the cleaner will go through. Remember, it was 82 meg. And I think I've waited long enough. Execute. The cleaner went through, cleaned up that 82 meg and said, okay, we cleaned up that aborted transaction. But I waited 60 seconds. I think I waited, yeah. So about every minute that cleaner's going through and making sure my PBS is constantly staying clean. I don't know if anyone just got it. That last 10 minutes was amazing. If you've ever had to do a recovery, I mean, every time I do this, I get amazed. I'm like, what is it? My recovery process took, was it 2 milliseconds or 0 milliseconds? My transaction log is almost non-existent now. And my PBS, my persistent version store, is cleaning up after itself. Is there any bad things? Well, we did talk about the size. The other bad thing is the updates. So if I go through updates, is going to take 13.8% more to perform updates. Not roll back, but to actually perform updates is going to take a little bit longer. If you'd like to know more about that, that's the rest of my sample code, where I do have sample code where you go through, turn accelerated database recovery back off, and then go through and try to do updates. So you can test update without ADR, test before and after checkpoint, the transaction log size, roll back. So everything I just did with deletes, you can walk through and see for updates. So you can see rolling back an update, the kind of difference the last time I did this, how long did it take? Or sorry, actually doing the update. About the same in my scenario. It was only 750,000 records I'm updating. But again, the benefit of rolling back, do I have it? Do I have the rollback anywhere? How long does, oh, I didn't put it. The rollback's going to be 0. I don't think I actually copied and pasted that. So if you do want to test the update, I do have the rest of the code there in my sample code, again, on my github.com/SQLMCT under performance tuning folder. Actually, I have all my performance tuning demo code, intelligent query processing, query store. So if you can figure out all my demo code, you have all of it. All right. So that was it. Is there any questions, comments, hints, allegations?
I'll go ahead and stop the recording.
Okay. Wow, that went long.